Okay, Trig kids, we're going to do half of 1-3 notes today, but there was a question on 52 at the end of the period yesterday on 1-2, so I'm going to go over that. That's a homework problem. And so, I don't know, it kind of starts out funny. We got to do the completing the square, but the problem is that there's like this 4 in front of the x and y. So we're gonna work on that and get that part figured out, and then we're gonna complete the square, and then we're gonna, put this into the circle formula. So I'm gonna just try. I know that not everything is divisible by 4 here because we got that 9 there, but let's just divide everything by 4 and let's just see what we've got going on. So 4's cancel. We've got should give myself more room. X squared. I'm going to put the x's together, so I'm going to put this minus 3x here, and then I've got plus blank, and then I've got this y, so I've got plus y squared. Now there's no y, so I don't need to put a plus blank on the y, so I really only have to complete the square, I guess, one time for the x's. This 9/4, I'm going to bump him to the other side, and if you want to write that as a decimal, that's totally fine, but he will be negative, and that's 2.25, okay? So maybe that's helpful to put him as a decimal instead. We've got to complete the square here. Ugh, this is going to be so gross. All right. So I want to figure out what I can put in this blank that when I multiply the two numbers together will give me that number, but when I add them, give me that -3. Okay. Now, this is not going to come out nicely. We know that this number has to be divided by 2 to figure out what that number is. So it's not going to be nice. It's going to be like x minus 1.5, right? -1.5 and -1.5 give you -3, but when I multiply them, it's like positive 2.25. So that's what we're going to add over here. Oh, I see a problem already. Okay, plus y squared equals -2.25 and positive 2.25 are going to cancel, so I have 0. Okay, so, I mean, we had a problem like this on the notes. I think it was the last one that we had right here. Yeah, example 4, where we have a circle with a center at this point and this point. Now, this point would be at positive 1.5, comma. The y doesn't have a coordinate, so he's 0. But then the radius, so center is that, radius is 0, right? Take the square root of that. So I only have, what?
I can definitely see it. A second ago.
Yeah. So the radius is 0, so I just have one singular point, and there's no circle there. So I don't know what the question in particular asked, if they asked for the center and radius or how many solutions you have, but basically this is just a point, and there is no circle that is being defined by this problem. So kind of weird stuff. All right, that's 52. Okay, I'm going to bump on to lesson 1-3. Yeah, so now we're talking about functions and relations, and I know that you guys have had this before. We would have talked about this in like algebra 2, but I'll just kind of do a refresher. So everything is a relation, like an x and a y are related to each other, but not everything is a function, and that has to do with like, are the x's repeating? Does a function when you graph it, or a relation when you graph it, does it pass the vertical line test? Okay, so we'll go through all that stuff, but we're talking about whether a relation is a function. Everything is a relation, not everything is a function, right? So in the physical world, many quantities that are subject to change are related to other variables. For example, the cost is related to the weight of a package. The minimum braking distance of a car depends on the speed of the car. So like this, let's see, I should say not minimum. I'm going to underline braking distance. I'm going to underline distance, okay? So the distance depends on the speed of the car. So when we're talking about like independent versus dependent variables, distance would be the y variable, speed would be the x variable, right? Cost is going to depend on weight. So weight would be the x variable, cost would be the y variable. The perimeter is the y, that's going to depend on the length and width. So I have like 2 input variables, we'll call them x and z, right? Or L and W, you can do that, whatever, right? Test score is y, it depends on the number of hours that we study. So hours would be the x coordinate, right? Okay, so x and y, dependent and independent variable, okay? Now, the definition of a relation, it says the set of ordered pairs x, y is called a relation because you're relating x and y. X is the domain and y is the range. I know you've seen those before, okay? We are going to, we haven't decided function yet. All right, so we're going to go to domain and range here. It says write the set of ordered pairs that defines the relation. This is a table that shows the number of hours you study and then the test score. So, I mean, Are they related? I don't know. Sometimes they are. Like this person studied 11 hours and they got the highest grade, right? This person studied 3 hours and they got the lowest grade. I mean, some of the other ones, this person studied 8 and 8. These two studied the same amount, but their test scores were different. So it's not going to be completely a one-to-one relationship where it's exactly perfectly linear, but I mean, they say that there is a relationship. So write the set of ordered pairs. I'm going to do that down here. So like this is just 8, 92, 3, 58, like all of these just listed out, right? This is like the easy part. Okay, 572 and 886. Okay, like that. All right. Write the domain. The domain is just going to be the x elements. So I'm going to do that really small under here. I don't know, you can put it over off to the side over here if you want to. But when I write the domain and the range, I list them in like there's curly Q brackets like this. Okay? I don't know if you've seen me do that before, but write the yeah, we've done that before. Write the domain. The domain is just these elements. And when I do the domain, I list them in order, and you don't list the repeats. So 3, 5, 8, and 11. Those, the 8 is not listed twice. Okay? The range, you also go in order, and you don't list the doubles. So 58 is the first one, 72, 86, 92, 98. Okay, there's that. All right, domain, range, set of ordered pairs, not too bad. Now we're going to decide whether something is a function or not a function. All right, now when you determine whether it's a function and you have the ordered pairs, you're going to do one thing. But if it's a graph, you can do something called the vertical line test. Okay, so let's talk about whether or not something is a function. I always go off of the fact that if it is a function, the x does not repeat. Okay? All right, if we were in class, I would do, well, I'll go ahead and do it anyway, and I'll try to recreate this list. So let's say the x is the year, and the y is the Super Bowl winner. Okay, I have no idea who won the Super Bowl this last year. We don't watch the Super Bowl very much. I don't know. I know the Chiefs won like 2 different times. I don't know. Let's say Eagles. I don't know. They were in there somewhere. We had the Chiefs. Whatever. I don't even know. I'm at a loss. Let's say the Chiefs again. I don't know. Whatever. So let's say this is 2025. You guys could all tell me, I'm sure. 2024, 2023. Okay, whatever, right? So here's the deal. You don't want the x's to repeat. None of those x values repeat. The y values are allowed to repeat. The Chiefs won 2 different years, right? That would make sense. That's okay to happen. But what can't happen is, let's say I had another 2023 and I had give me another team that would have played in the Super Bowl. I don't even know. The Cowboys, I don't know. They're not going to play in the Super Bowl, but anyway, I don't know if you guys, okay, whatever. So there's that. That can't happen, right? I can't have 2 teams win in the same year, right? They're like that. The x's aren't allowed to repeat. That's the dependent variable. That's not allowed to happen. Okay, I'm allowed to have the y's repeat, but not the x's repeat. And so that's kind of an illustration of how that works. All right, so function, not a function. Okay, determine whether the relation is a function. A, let's see, 3, 2, -4, -1, 3. The 3's repeat, so this one is a no. All right. This one, -1, 2, 3, -4. That one is good, even though I have a 4 here and a 4 here. The y's can repeat, but the x's cannot. And so since the x's don't, that is a yes. Okay? I'm going through this kind of fast because I'm pretty sure you guys have done this like a million times before. Okay? It's not a real hard concept. Okay? Now, using the vertical line test, let me show you how this illustrates down here. This one up here that was a no, right? Okay? The vertical line test says that if you graph a function, it should only pass through each place on the graph one time. And if it hits only one time, then it is a function. Like this one, it's going to hit in 2 places, which means it's not going to be a function, right? Okay, so this one is a no for the vertical line test. This one is a yes because he's only going to hit at each of those 1 places, okay? Now up here, the reason why this is consistent with this thing up here is, let's say I graph those 2 points right here, 3, 1, 1, 2, 3, 1 right there, and 3, -4 down here. Those, if you graph them, hey, they're going to hit at the same vertical line, and that's not going to work either, right? So this does follow the same concept as the vertical line test. It's just that you can, do an easier method by just making and looking at the x coordinates and making sure they don't repeat. Okay, so let's look at C now. Is C a function? Does it pass the vertical line test? Yep. Wait a minute. There's two of them right here that are both filled in circles, so that does not pass. If, let's say, this was an open circle and this was a closed circle, then he would pass, and that would be fine, right? But this is a no. The fact that he has a jump or a break right here, he's a piecewise function. My calc kids, you know what that is. That doesn't matter. That doesn't have to do anything with the fact that he's a function or not a function, right? Okay, we just don't want to hit in two places. Okay. All right, now there's more of these. Let's determine whether the relation is a function. So if I look at this is something called a mapping diagram, by the way. Okay, and so if I look at these as an ordered pair right here, like this is 1, 2, 1, 2, right? This is 3, 2, okay, and this is 5, 4. All right, that is legal, even though the y coordinates repeat, the x's don't, so this one is a yes, he is a function. Yes, function. Okay, now B, you really kind of have to know what this parent function looks like, all right? You should know what this parent function looks like, y equals x squared, all right? And I think most of you know what this one looks like also. Y equals x squared is a parabola that looks like this. X equals y squared is a parabola that looks like this. Now, if you didn't know that, you could plot some points, whatever. But x equals y squared is going to be turned on its side. Therefore, it does not pass the vertical line test. So no, this is not a function. Y equals x squared, yes, this one is, because he will pass the vertical line test. But x equals y squared, no. This one, okay, what does this one look like? This is the equation of a circle, right? Centered at 2, -1, right? Opposite sign. And the radius is 3. So we have a circle. If I think about what the graph of a circle looks like, wherever he's positioned, 2, -1, doesn't really matter, right? Like over here, whatever, he's not going to pass the vertical line test, right? We didn't even have to graph it. We didn't even have to locate the circle and center and the radius to know that that one's going to be a no, right? If he's the equation of a circle, he's not going to pass. Okay? All right, I'm just going to do a little bit more. Let's do 5 and 6, and then we'll save the rest for tomorrow. Yeah, let's do 5 and 6. Okay, so now they're gonna graduate us into something called function notation, which we're used to saying all the time. Like, we're big kids now, right? Long gone are the days where they say y equals x minus 2, right? They call it f of x equals x minus 2, and that's function notation, so that we can read it as like f of x equals x minus 2. All right, the function of x is x minus 2. Okay, so f is the name of the function. Sometimes they'll have like h of x or g of x or whatever, right? Or s of t. I think in calc we're doing stuff like s of t, where s is the position function, like the height at a certain time, whatever. That's all function notation. X is the input variable, f of x is the y value, or the dependent variable in the output variable. Okay, so function notation, they have a function here and they call it g of x, and it is 2x plus 1. All right, so when they ask for g of -2, like, all you're doing is plugging -2 in for x in that spot, right? Like, we know this. Plus 1, so 2 times -2 is -4, plus 1, so the final answer is -3, okay? If I plug -1 in there, 2 times -1 plus 1, this is -2 plus 1, or -1, okay? If I plug 0 in, I have 2 times 0 is 0, and plus 1 is 1, okay? If I plug 1 in, 2 times 1 is 2, plus 1 is 3. There you go. There's your all the way across. Okay. Oh, wait. I have g of 2 over here. 2 times 2 plus 1. 4 plus 1 is 5. Okay. Fairly easy. You're just plugging those numbers in. You're finding the output value if your input value is whatever. Okay. Now, they make it a little bit harder in example 6 because they do this to us. Like, let's say f of a. Well, if f of 2 meant you plug 2 in, f of a means you plug a in. Now, there's another thing here. This function has 2 x's, so which one do I plug in for? Both of them. F of a is going to look like 3 times a squared plus 2 times a, right? And then how do I simplify that? Well, it's not going to simplify to be a number like this. If you're putting a number in, you should get a number out. If you're putting a variable in, you should have a variable in your answer, right? So this one, 3a squared, is just going to be 3a squared, right? Plus 2a, okay? Now notice up here that you're not also squaring the 3. The 3 is not inside the square with the a, so this is not 9a squared. It still stays 3a squared. This is going to be all that you can simplify him to be. All right, now b is really gross. My calc kids, x plus h, they are getting you ready to, I wonder if they do that in this section, or maybe it's the next section where we talk about the limit formula, f of x plus h, right? Minus f of x over h, and the limit as h goes to 0. Does that look familiar, right? They're setting us up and like, oh, this is something that you might see in the future. Yep, we just got done doing that in calc, so whatever. Anyway, f of x plus h. They want us to plug in x plus h into my equation there and there. So 3x plus h squared plus 2x plus h, okay? And this is going to require us to FOIL, which is a little bit unpleasant, but that's okay. Calc, you've done this before. X plus h times x plus h. If I FOIL, x squared plus an xh in the middle plus another xh. If you want to put those together, you can. H and h is h squared. So this is x squared plus 2xh plus h squared. That looks like the plus h squared. There you go. That's that. Okay, now I have this 3 in front of all that, right? This was here, and I have that 3 in front. So as I bring him over here, I'm going to multiply that 3 through. So I've got 3x squared plus 6xh plus 3h squared. That's this part, okay? And now I've got this part yet. So plus 2x plus 2h, and final answer, I'm going to put all that together. So 3x squared. I can't even combine any like terms, so he's done. Okay? That is all. Yeah, there's nothing else I can do. Okay. So, that's it. That's what B is, all right? You plug in x plus h, you're going to get x plus h's in your answer, all right? So you should be able to, I'm not sure how much you can do of the homework. I don't even have the homework assignment yet up there. Hold on. I gotta switch to a different computer and figure out what your homework assignment is. Ugh. Okay. Ooh. Page 42, 10, and 12, and 18, and 22, and 26, and 28, and 32, and 38. I'm sorry. 78, and 88, and 90, and 94, and 98, and 100, and 112. There you go. Sorry, that was a lot, but you don't all have to do it all today. I don't have my book with me, otherwise I tell you how far you should be able to get. But you should be able to get through all of the stuff and like stop where it says determine x and y intercepts, or keep going if you think you can do it, right? So there is that. I will send you another video in tomorrow, like for Thursday, whatever day. I don't know my days anymore. If you're going through these homework problems and you're like, oh, I'm stuck on this one, shoot me an email right away, and maybe I'll add that to the beginning of the next video, right? Like that I'll do a homework problem for you. So if there's any of them that you want me to add, let me know, and I can include that in the next video. Okay? All right, goodbye.